The potential for life on the planets around us has also changed as our sun has evolved. History shows that the balance between habitability and safety is delicate and doesn't last forever. Earth is the only planet to have retained water and habitability. Earth's stability is remarkable. It has kept oceanic conditions on its surface for billions of years. This is what has facilitated Earth's very rich and diverse biological evolution. Earth is a special place. Earth is the only place where we can say with certainty that life exists in the universe. You need liquid water to sustain life on a planet. The size and geology of our planet make it a unique place. For billions of years, the atmosphere has been stable enough to protect the precious water, which has supported the evolution of complex life. The fabric of our planet is woven with life. It has formed the continents and oceans, and now the atmosphere itself protects fragile ecosystems. As the sun heats up, temperatures on Earth will rise, causing the weather to change. Patterns will emerge that bring on great storms and droughts around the world. In a billion years, as plants die around the globe, oxygen levels will plummet, and the era of complex life on Earth will be coming to an end. Earth will eventually be like Venus and Mars, but with more CO2. It will be a hot, dry planet. The sun will eventually become a red giant when it runs out of hydrogen. As we have seen with other stars in our galaxy and the universe at large, our sun is going to continue to heat up over time. At that point, the sun will continue to expand until it reaches a stage where it is classified as a red giant star. The Earth will be nearly completely engulfed. At that point, all the planets will lose their atmospheres. They'll be swept away when the sun runs out of hydrogen fuel. As our star enters the red giant phase and expands millions of kilometers into space, the sun's outer edge will inflate. Mercury will be the first to be engulfed. Venus' fate is sealed. According to some models, Earth will barely be able to escape the fate of its neighboring planets, with Mars clinging on at the edge as the star dies. The long epoch of the four terrestrial planets is over. Lives lived on one. It's a distant memory. Uranus. Truthfully, it has some rather unremarkable clouds. There wasn't much to see when the cameras passed close to Uranus. Voyager's sensors explain why Uranus has so few features. The temperature here is the coldest in the solar system. The storms seen on Jupiter and Saturn are simply too cold to be a driving force here. Uranus belongs to a completely new class of planets. A giant ice ball. There were more surprises to come. Telescopic observations have shown us that Uranus is encircled by a ring. Uranus has rings. We did not know the shape or configuration of these rings. Voyager explored the rings and noticed something strange in the shadows. The system was organized by two moons, Cordelia at the inner edge of the brightest ring, and Ophelia at the outer edge. The particles within the rings can be moved either inward or outward, as these small objects act like shepherd moons. Their gravitational forces can shape the rings. It's not the rings or the moons themselves, but the way they orbit. Uranus is the most bizarre of all worlds. Uranus is a strange planet, with its rings appearing odd. You can observe them with a telescope that you can find by searching online. They're actually orbiting over and around the top of the planet. The entire planet is tilted like a top. This strange orientation suggests an unusual past. Everything in the solar system has been moving in the same general direction since its formation. The process begins with an enormous cloud of material orbiting the young sun. The material is drawn together over time to form each planet. They all still orbit the sun today and rotate on their axes in the same way, counterclockwise. Venus and Uranus spin in opposite directions. Uranus, however, is even more bizarre because it is a planet that is tipped on its side. This system is really odd. Why is Uranus tipped so far to one side? If an object the size of Earth slammed into Uranus at a late stage in its formation, it would have the right amount of force to knock it over. The collision could also explain Uranus' other mysteries, like why the planet is so cold. This impact is thought to have robbed the planet of much of its internal heat when it was first formed, leaving it as a relatively inactive and frigid world. Voyager was about to make some of its most bizarre discoveries. What is the source of power for weather? The weather is different depending on your location in the solar system and Earth's atmosphere. But on Earth, weather is largely driven by the sun. The sun sends its energy through the atmosphere. It hits the surface, and then the Earth's surface warms. The energy from the sun heats up the surface and creates thermal waves, which then drive the atmospheric flow. Saturn, for example, does not have a solid surface that can be heated. When you compare these weather systems to the ones on Earth, it's necessary to rewrite the rules a bit. Saturn is located in the outer solar system, far from where the sun controls Earth's atmospheric conditions. The sun is 100 times less powerful at Saturn. This means that another heat source is driving Saturn's weather, which is incredible. Cassini was able to infer an enormous amount of information from the tops of clouds on Saturn. Imagine the strange world below, the energy source that powers this planet. One of our main goals was to better understand the atmosphere of Saturn and the forces that drive the winds we observe. We have now confirmed that the energy for the atmospheric systems of Saturn is actually derived from within the planet. This heat source is internal to Saturn. The sun doesn't power them like it does on Earth. Deep inside Saturn, extreme pressure has shaped a source of heat within huge clouds of liquid and gas. Cassini recorded lightning that is 10,000 times stronger than anything on Earth. This lightning turns methane into huge clouds of soot at an 8,000 kilometers depth, where the atmosphere has a pressure 80 times higher than that on Earth. At the bottom of the deepest oceans, this carbon soot can be transformed into diamonds. However, Saturn's pressures will likely destroy even these diamonds. Saturn's heat source is revealed to be 30,000 kilometers down. Saturn's heat is revealed here. The atmosphere is so compressed that it behaves like a liquid metal capable of conducting electricity. As helium melts and merges with its surroundings, it releases kinetic energy in the form of incredible heat. Saturn's weather is influenced by this internal heat source. Sent to search for conditions in which life might have started, is NASA's Mars Reconnaissance Orbiter. MRO returns more data than any other Mars mission combined. MRO is equipped with 3 cameras. The first camera is the Mars Weather Cam. The camera sees from horizon to horizon on every orbit. It builds up a daily map of the entire planet. You can view a global map of the weather every day on Mars. The second is the Cantex camera. It offers high resolution and covers about 99% of the surface. MRO has completed more than 60,000 orbits. Mars is revealed in unprecedented detail by its high-resolution camera. Finding polar avalanches, sand dunes that move, what appears to be seasonal flows of sand or liquid meltwater. In 2017, MRO will turn its attention to the oldest feature on the red planet, Eridania, a basin in the oldest crust of Mars, which is a large basin. The water in this ancient ocean was 10 times saltier than when it was formed. The basin is 3 times larger than the Earth's Great Lakes. MRO has discovered something amazing on the ancient seabed. MRO observed a 400-meter thick deposit that was formed by a mineral found in deep-sea hydrothermal environments, such as those with undersea vents. Mars had all the ingredients necessary for life as on Earth. It also had an active, dynamic environment that could have sparked it into action. Eridani, an ancient sea, was a basin 4 billion years ago. This is about the time that life first appeared on Earth. It is possible that life existed in this area because the hydrothermal vents under the sea could have created an environment very conducive to life. The initial conditions of the 2 planets and their history are so similar. It is reasonable to assume that they could have eventually led to life. It is believed that these active, fertile conditions have survived in places such as the Eridania Basin for many hundreds of millions of years. Then, 3.7 billion years ago, something happened that forever changed the prospects for life on Mars. Mars' climate underwent a significant change. The climate became colder. The liquid water either soaked into the ground, froze there, or froze on the surface. It would eventually be transported to the poles, where it would form these big, thick ice caps that we see today. The temperature dropped at the same time. Mars's volcanic activity increased, kilometers long. The water disappeared once the flood subsided. It is the only evidence that it ever existed. The surface of the planet is etched with symbols. Neptune is an ice giant that has 17 times the mass of Earth. It's also over 1.5 billion kilometers farther from the Sun than Earth is. Neptune and Uranus are almost identical in chemical composition. They couldn't possibly be more different. Neptune was a bit of a relief, because it did have some features. It was good. It's the same type of planet, but with new features and clouds. Neptune brought a lot of excitement. There are swirling clouds and really strong winds. At 2,400 kilometers per hour, they are incredibly fast. The fastest wind speeds in our solar system. Voyager found a large, swirling dark spot in the atmosphere. We call it a giant storm. Just those words are enough. It's a storm that is the size of planet Earth, or even larger. Even though the planet is much further away, there are still surprises. Voyager discovered that Neptune was warmer than Uranus. The source of heat is also another strange feature of this strange world. We are completely baffled by this activity, which is occurring in such extreme cold. According to one theory, the pressure buildup beneath the thick layer of clouds turns the carbon content of the methane gas into diamond rain. Then, as they descend and fall to the planet's interior, extra heat is produced. The heat from the core warms the air, causing winds to blow around the planet. The flowing fluid is not hindered by mountains, valleys, continents, or other boundaries. Dynamical flows. This means that there is very little that can stop a weather pattern from starting, such as when a vortex starts spinning or a plume begins to rise. The winds that are developing and going around just keep on going. Nothing can slow them down. There is no friction on the surface. The extreme cold makes the air less viscous and creates supersonic wind speeds that are faster than anything on Jupiter or Saturn. Mercury is the least studied of all the rocky worlds due to its proximity to the Sun, making it difficult to orbit. A planet so near the Sun is not an easy target. Launch of Messenger, NASA's Mercury mission to explore an enigmatic planet in our inner solar system, taking a direct path to Mercury through the sound barrier would not be practical. The spacecraft would arrive at high speed and would have to carry a large amount of fuel to slow it down. Instead, Messenger slows itself down by using the gravity of each planet it passes by. Messenger has to make 3 FLYBYS of Mercury, slowing down each time, until nearly 7 years after launch, and with flawless navigation, it reaches orbit safely. With this first image, it was able to start its mission of mapping Mercury's surface. It was the most amazing thing I've ever seen. It finally arrived and looked great. We were not disappointed. It was at that moment that I realized we were in orbit successfully and that everything was working. This pioneering journey has given us a new understanding of Mercury's formation. Mercury is the planet with the most craters in the solar system. It has many puzzling characteristics that suggest a violent history. Mercury's orbit is very unique. The planet's core is also of a very unusual shape. Mercury is a large ball of metal surrounded by a thin layer of rock. How can you have a planet with so much metal in its interior and almost none on the surface? It was a big mystery. The major question now is, why? Why does it look like that when other planets provide clues to these odd features? Mercury's chemistry holds the answer. We started receiving chemical data from the surface very quickly after entering orbit. and we were immediately surprised by some of these results. What was surprising is that the probe was able to detect volatile chemical elements in concentrations that no one thought possible this close to the Sun. These are elements in rocks that can evaporate at low temperatures. This immediately told us that the old ideas about how Mercury formed were not correct. What Messenger found out about Mercury may suggest it whisked to the story of our solar system just a few million years after its formation. Mercury, as a young planet, is sweltering with heat from its violent birth. Slowly, a crust-rich in volatile elements forms. These elements would have evaporated if the rock had been exposed to sunlight. What could explain the high levels of volatile elements on Mercury today? Over the course of history, the orbits of planets have changed. Where they are now doesn't necessarily mean they were formed there. It is possible that they moved from another location to the one where they are today. Mercury may not have formed where it is now. It might have formed farther out, closer to Venus or Earth. Mercury's fate could have been different if it had formed close to Earth and kept a comfortable distance from the Sun. But it was not to be. What happened to make it the strange, sun-baked world that we see now? We don't have the whole story. We have theories. We are constantly trying to adjust our theories to fit new observations. Messenger's evidence for the volatiles on Mercury's surface and its unusually large core suggest an interesting new hypothesis. Mercury could have been born as far as 160 million kilometers from the Sun than it is now. Mercury could have been pushed out of its initial orbit by gravitational interactions with something large in the area of space where the Earth's young planetary body was forming. At that time, there were also scores of planetary embryos battling for position. Mercury collides with another planetary embryo with a glancing blow. This collision strips away much of its crust and mantle. Mercury is now little more than a metallic planetary core. It continues to move towards the Sun and ends up in the peculiar orbit that we see today. Before we sent Messenger to Mercury, I believe we had an overly simplistic view of what the planet would be like. Mercury is a much more complex and interesting place than we thought. All things must come to an end. Once we ran out of fuel, Messenger's thruster engines could not be used to prevent a collision with Mercury. It crash-landed on the planet's surface. Messenger's fuel runs out after 4 years in orbit. The spacecraft makes its final contribution by adding yet another crater to this tiny planet, a world once thought to be too inhospitable for any kind of exploration due to its proximity to the Sun. The outer corona of the Sun blazes at 1 million degrees and releases a torrent of charged particles traveling at 400 kilometers per second. The solar wind is a relentless stream that would have stripped away our atmosphere if not for the Earth's powerful magnetic field. The solar wind is a stream of charged particles emanating from the Sun and heading towards Earth. Interactions with this field can divert charged particles away from Earth when they are getting close. This shield keeps solar wind and other ionizing radiation off the surface. On Earth, thanks to its strong magnetic field, we are protected from radiation by this protective shell. Earth's magnetic field forms a protective bubble that surrounds the Earth's atmosphere. This protective force is sometimes visible when the Sun sets below the horizon. The aurora is an amazing display of Earth's magnetic field in action. This vital protective shield is generated deep within the Earth through the motion of electrically conducting fluids. It can be seen best in the polar regions, but it protects our atmosphere and life all over our planet. This vital shield is created deep inside the magnetic field. In a planet, a magnetic field is created when there is convective movement in a liquid that can conduct electricity. On Earth, this electrically conducting fluid is molten iron. The molten core of the Earth is where these movements take place, creating a magnetic field similar to Earth's. Mars had a metallic core that was once molten, creating a magnetic field around the planet. Auroras danced over Mars' poles, protecting the atmosphere and oceans beneath. This field did not last. In the oldest Martian rocks, you can see remnants of a powerful magnetic field. In the younger rocks, the ones that are less than 3 billion years old, such as rocks that are 2 billion and 1 billion years old, there is no evidence of a magnetic field. Today, Mars lacks an intrinsic magnetic field. Mars' magnetic field faded away about 500 million years after its formation. As the planet's shield weakened, the auroras that were visible above its poles gradually faded. Without the magnetic field, atmospheric elements like hydrogen, which is a component of water, started to escape. Without the protective magnetic shield, high-energy particles from the sun and outer space began to strip away components essential for water. Mars' atmosphere and water were left vulnerable and began to slip away into space as its magnetic field was no longer there to protect them. Why did Mars lose its protective shield? What happened beneath Mars' surface to prevent it from developing like Earth? Understanding Mars's creation is key to unraveling what happened. Mars's story begins 4.6 billion years ago when planets formed from dust clouds orbiting the Sun. Mars and Earth, though similar as young planets, diverged due to different conditions and materials available in their early paths. Mars formed farther away from the Sun, where there was less rocky material available to build a planet. Not only is Mars farther away, but it's also significantly smaller. When a planet is too small, its core cools down and eventually solidifies. Mars has a diameter about half that of Earth's, which caused its core to cool more quickly. As it lost heat, the dynamo effect that powered its magnetic field ceased. Mars' small size condemned the planet to lose its magnetic field much earlier. Saturn has a moon that is 400 kilometers across and is composed entirely of ice. This moon is doomed. It is orbiting too close to Saturn's gravity. The rings likely formed when an object got too close to Saturn. The Roche limit is an invisible boundary surrounding Saturn. It varies depending on the material of the object. If you cross it, Saturn's gravitational pull becomes strong enough to pull you apart. The gravity at the side closest to Saturn is much stronger than on the opposite side. Objects don't have enough gravity to hold themselves together within this limit. According to a leading theory, just beyond or within Saturn's Roche limit, Saturn's enormous gravitational pull tears a moon apart as it approaches. The moon catastrophically ruptures, torn apart by Saturn's immense gravitational force. Due to the speed at which this material travels, it's possible that in just a couple of days it will have spread out and encircled the giant planet. Saturn's iconic rings are now in place. But as Cassini turns its instruments towards them, the rings reveal changes. The images that we received were incredible. The resolution was 20 times higher than before. We had never seen anything like it. Cassini reveals how Saturn's giant ring system has evolved. The debris has now formed a disk that is wider than Jupiter. The structure is only 10 meters thick, but various forces can create vast gaps and turn one ring into several. Cassini's pictures, taken with the sun directly above the equator, reveal an astonishing feature of the rings. This was an opportunity for us to explore the third dimension. It's not visible in regular images of Saturn's rings. What we discovered was astounding. We immediately saw vertical structures. This was a complete surprise to us. The discovery was unexpected. I imagined myself flying in a spacecraft along the ring, right next to the rings. From my perspective, it would look like an endless sheet of shining debris. I am flying and flying. Suddenly, I encounter a 2-mile-high wall of debris. Can you imagine that? I've said it before, they should make a movie out of this. This once small world of rock, ice, and water has become the most beautiful jewel of the solar system. Cassini's more than 10 years of orbiting Saturn have deepened our understanding of the planet. Its mission continues. The young Jupiter is circling the Sun, cutting a path through the gas cloud surrounding the early solar system. However, this process causes it to behave unpredictably. Jupiter spirals inwards and plows through the region of space that would become the asteroid belt. As the young Jupiter passes through the primordial asteroid belt, its gravity scatters the objects within it. As a result of these gravitational interactions, the asteroid belt loses more than 99% of its original mass. Over time, the giant planet's movements disrupt the asteroid belt. This scatters material from the asteroid belt into the outer solar system. There wasn't enough material in the orbital neighborhood for these protoplanetary cores to become full-fledged planets. Jupiter's passage through the primordial asteroid belt starved the material needed for the dwarf planet Ceres to grow, leaving it as a cold, barren rock. Ceres wasn't the only body in our solar system whose development was stunted. Mars suffered a similar fate after Jupiter passed through the asteroid belt. Jupiter continues its spiraling journey towards the Sun, entering the region of space where Mars has formed. Jupiter's immense gravity scatters material as it moves through space. Some of it is sent soaring towards the Sun while some is flung into interstellar space. Mars's growth was limited to less than 10% of Earth's size due to Jupiter's gravitational influence. Mars is small because Jupiter cleared material from the inner solar system, which also prevented super-Earths from forming. Other solar systems have super-Earths. If Jupiter had kept moving inwards, our planet might not have formed. Jupiter halts just before it could potentially sweep everything away. In the outer regions of our solar system, another planet, Saturn, is forming. Saturn, the second gas giant in our solar system, changes everything with its arrival. Saturn's orbit aligns with Jupiter's as Jupiter moves inwards. The two planets then lock into a special configuration called mean motion resonance. In this configuration, the planets interact in a very synchronized way, acting as a single unit. Both of them reverse their migration and move outward. Saturn's outward migration causes Jupiter to retreat, leaving behind just enough material for the inner planets to form. Mercury, Venus, and Earth form. Earth has the perfect environment to support life. Who knows what would have happened if Jupiter had moved even further inwards? Life might not have evolved in the solar system as we know it. As Jupiter's journey across the solar system nears its end, it provides our world with an essential ingredient: water. Oceans cover 2/3 of Earth's surface. Each drop of the 1.3 billion cubic kilometers of water teems with life. How Earth received its water is one of the biggest questions in the evolution of our solar system. It is believed that the inner planets did not naturally form in a water-rich environment. Water is abundant in the outer solar system, but as Jupiter and Saturn move outward, they bring water to the inner solar system. Jupiter is locked in a gravitational dance with Saturn and the asteroid belt. As it moves through the asteroid belt, it flings water-rich material inward, where it becomes incorporated into the forming terrestrial planets. The movement of the giant planets played a significant role in delivering water to the inner solar system. Jupiter's migration through the asteroid belt is credited with bringing water to Earth. Without Jupiter's influence, Earth would have been a very different planet. Around 100 million years ago, Jupiter ejected an asteroid 10 kilometers wide from the asteroid belt. The asteroid is now on a collision course with Earth. The impact creates a fireball so hot that anything within a 1,000-kilometer radius dies instantly. This explosion ejects 300 billion tons of sulfur into the atmosphere. During the ensuing nuclear winter, 75% of species are affected. The largest animals and plants are wiped off the face of the Earth. Jupiter played a role in driving the dinosaurs to extinction, paving the way for humans to inherit the Earth. Jupiter protects us, even though it occasionally sends asteroids our way. Its enormous gravity acts as a protective shield against objects heading towards Earth from the outer reaches of our solar system. Around 100 years ago, a lump of ice and rock measuring 4 kilometers in diameter was hurtling towards the inner solar system. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter. A mission launches 70 years later to see just how effective Jupiter's shield can be. The Galileo orbiter is mounted on the Atlantis space shuttle. 3 years after Galileo's launch, comet Shoemaker-Levy 9 was captured by Jupiter's gravity and is now entrapped in its deadly embrace. As it moves into the inner solar system, tidal forces begin to tear the comet apart. This presents the Galileo scientists with a unique opportunity. Everyone is watching. They realize two things. The comet had passed very close to Jupiter and was probably ripped apart by Jupiter's tidal forces, and it was about to collide with Jupiter. The discovery, 2 years later, that a comet was about to hit Jupiter was both surprising and exciting. Galileo, after crossing the inner solar system, is now approaching the place where it will witness the final moments of the comet. Galileo is in a position to directly see the impacts. The impacts occur on Jupiter's night side, and Galileo has a clear view. On July 16th, Galileo witnesses the first comet fragments entering Jupiter's southern hemisphere at a speed of 60 kilometers per second. The pieces of the comet heat up the atmosphere to temperatures close to that of the Sun and strike the planet in succession. Over the course of 6 days, pieces of comet Shoemaker-Levy 9 hit Jupiter. The images show large flashes on Jupiter. The photos of the impact are extraordinary. These tiny points of light, captured from 240 million kilometers away, are the first time a comet impact has been observed. The most powerful impact releases energy equivalent to 6 million megatons of TNT, leaving behind a giant dark cloud 12,000 kilometers across. By capturing objects in its orbit and incinerating them upon impact, Jupiter protects Earth from bodies that might otherwise collide with it. Jupiter serves as a shield, protecting us from celestial objects that might otherwise pose a threat to Earth.